Good day, everyone. Today, I want to introduce you to what's going to be the last piece of new material that we're going to learn, and that is volume. And we're going to learn different ways to use integrals to figure out volume. Now, what I'm going to try and introduce to you here is volume based off of cross sections. Okay, that's the first type of volume problem we're going to do based off of cross sections. So what I got here is one of these very hard to get loaves of bread. Okay, and let's just pretend I had to figure out the volume of this loaf of bread. Okay, so one idea of how to do that is to take a cross section. Okay, a cross section of a loaf of bread is if you look at it, this way, and so it's one piece of bread. Would be that shape right there would be a cross section of the loaf of bread. Okay, so if the width of this was 1 unit, let's just say each of these pieces of bread are 1 unit wide. To find the volume of this entire loaf, what I could do is just find the area of this and add all the areas of all these. And that should be the entire volume if this is 1. So the area of one piece of bread times however many pieces of bread there are times 1 would be the volume of this object. Okay, so to relate that to integrals, we're accumulating all of these pieces of bread. And what if you slice them infinitely thin so that the width of them was basically nothing, and you had infinite number of pieces of bread? What you'd have to do is add all of them together, which of course we know is an integral. So one way to find volume is the integral from whatever to whatever, a to b, of the area of a cross section. Okay, now we don't know the formula for this shape, but we're going to have known shapes, rectangles, squares, circles, things like that, that we're going to plug in for A. So that's the idea of volume based on cross sections.